Okay, this is the second video of 2.4 day 1, and I'm going to go ahead and introduce the trig rules to you and how chain rule and general power rule apply to the trigs functions. So these are all the trig functions that you guys were to memorize, and you should have memorized. The first one, and what I want to do is I want to explain to you this notation. This d over dx, remember, stands for the derivative with respect to x. We don't have x's in this problem. That's why at the end here they say that the derivative with respect to x is the sine of u and then a u prime, meaning they're taking the derivative of u. So let me explain that just using a small example. If I ask you to find the derivative of sine of x squared, this isn't just an x anymore. So we don't know the derivative of sine x is cosine x because it's not just an x. What we want to say is that the derivative is cosine of whatever the u was. In this case, it's the x squared, times the derivative of that u. The derivative of x squared is the 2x. So this is in essence, the composite function. They've replaced x with x squared. So now you kind of have the general idea of what that u prime and u stand for. We'll do a couple other examples. The first one I'll do is number 4 on page 137. I am just going to start taking this derivative. So I'm just going to write y prime. Anytime we have a constant, we've talked about this many times, we bring down the 3. So we just bring down the number that's out in front. The derivative of tangent is secant squared. Now, this wasn't just a plain old x, and that's okay. This is my u. I'm going to write the u as it is. So because this wasn't just a plain old x, I have to remember to take the derivative of this highlighted part. The derivative of what's inside then is 2 pi x. I would rewrite this. I would put together my 3 and my 2 pi x. That would give me a 6 pi x times secant squared pi x squared. That's as far as I would simplify this problem. Moving on to another example. We'll go back to some that don't have the trig functions in them. This one, I'm going to go ahead and rewrite negative 3. And this would be 2 minus 9x to the 1/4 power. Much easier to take the derivative once we have rewritten it. So the derivative of y ends up being, bring this out in front, you're going to hear me say this many times, negative 3/4. Rewrite it to minus 9x, lower it by 1. So 1/4 minus 1 is negative 3/4. Now the last step is to take the derivative of what's inside. The derivative of the 2 is 0, and the derivative of the negative 9x is negative 9. That is the chain rule in itself. So I brought the number out front, rewrote it, lowered by 1, take the derivative of what's inside. Last thing I'm going to do is simplify this very quickly. I'm actually going to end up getting, when I multiply the 3/4 and the 9 together, I'm going to get a positive 27/4. And then I have the 4th root of 2 minus 9x cubed on the bottom. And I'll continue on video number